how to solve gas stoichiometry problems. So let's look at the actual steps. So first step, as always, write a balanced equation for the reaction. Right. Next, right, really important that you know your formulas. Really important to know your balancing, because if we weren't able to balance that last equation, we were going to get that answer wrong, obviously. Next one, write the given information under the appropriate reactants and products. Right, so so what is given, write it underneath those compounds in your formula once you've written out your balanced equation. Put a question mark under the reactant or the product for which the information is what you need to find. Right? Convert all the amounts to moles. Right, so find the actual mole ratios. Compare molar amounts using stoichiometry ratios from the balanced equation. So solve for the unknown molar amount, which is what we did with the first sample problem, and then convert your new molar amount into the units required. You may multiply by the conversion factor or use a set of conditions with the ideal gas law. So sometimes you may need to find the number of moles of your unknown in order to be able to then use the ideal gas law. Okay. So let's go through the next sample problem here. Ancient alchemists like to use strong sulfuric acid to produce dramatically dangerous effects. One interesting reaction occurs when sulfuric acid reacts with iron metal to produce gas and an iron 2 compound. What volume of gas is produced when excess sulfuric acid reacts with 40.0 grams of iron at 18.0 degrees Celsius and 100.3 kilopascals? So, we've read it once. My advice to you, read it again. Right? It seems almost like a tongue twister. It seems like, oh my goodness, there's so much information that's being given, but break it down. Right? Go through it again. So, what I'm going to do is, let's save argument. So you can pause it right now, or you can kind of just follow along. So pause it, take a moment, figure out what is the actual formula, or what is the actual, or write out your balanced equation. Remember, that's the first step to any type of stoichiometry problem. Write out the balanced formula, or balanced equation. So, balanced equation, just writing out some of the givens. Balanced equation is as follows. Iron, in solid form, plus the sulfuric acid, in aqueous form, produces hydrogen gas, and iron 2 sulfate, right? It's some kind of an iron 2 product, so you have to figure out, and if you look at this, it's a single displacement reaction. So I've got a couple of our givens off to the side here. We've got the mass of iron, which is 40.0 grams. We've got the temperature, which is 18.0 degrees Celsius, and we always want to convert temperature to Kelvin, so equals 291 Kelvin, and we've got the pressure of 100.3 kilopascals. So, as we said, the next step, what we want to do is write out what our givens are. So one of the givens is 40.0 grams of iron. So it's asking us now, what volume of gas is produced? If you look at our formulas, the only gas that's produced is hydrogen gas. So that's what we're trying to find. Right? That's the one we're trying to find. So, using the information that we're given, well, we've got iron. So we want to find actually the number of moles of this iron. And so what we do is, well, we know the number of moles of iron is equal to, well, the mass divided by the actual molar mass of Fe, right? So you want to find the molar mass of Fe. And the molar mass of Fe is 55.85 grams per mole. So divide those and we get 0.7162 moles. Okay, so that is the number of moles of iron, Fe, 0.7162. So we're comparing iron and we're comparing the hydrogen gas. So we know, using the stoichiometry chart that I've used in the past, we'll go back to the old lessons, right? We have the following. We've got our unknown, right, which is hydrogen. That's what we need to find. We've got our iron. We know moles and the old-fashioned molecules, right? So it's a 1-to-1 ratio, so 1-to-1. What were the number of moles of iron? Well, the number of moles of iron, we just found 0.7162. We are trying to find the number of moles of the actual gas that is actually produced in excess, right? So what we can do is, well, we separate the two and write it down as a fraction. X over 0.7162 equals 1 over 1. But because it's a 1-to-1 ratio, what are the number of moles that are produced of hydrogen? And the number of moles produced by hydrogen is no longer an unknown, but because it's 1-to-1, it means it's going to be the same. So the number of moles of hydrogen gas will also be 0.7162 moles. Okay, so the number of moles produced is the same. So what volume of the gas is produced when excess sulfuric acid reacts with the 40 grams of iron, but it's at 18.0 degrees Celsius, right? So what we're going to do is use our ideal gas law. So what we're trying to do is, what volume of the gas is produced? So what volume of hydrogen is actually produced? So we're going to isolate for V. So another bit of information that we should put in our given is our R value. And our R value is 8.314 kilopascals liters per mole Kelvin. So what we're going to do now, we're going to substitute into this equation. So V is equal to our N, which is 0.7162 moles. I like to include extra significant digits and then round off at the very end. My R value, 8.314 kilopascals liters per mole of Kelvin, multiplied by our temperature in Kelvin, which is 291 Kelvin, all divided by the pressure, which is 100.3 kilopascals. Now, the next thing I like to do, cancel out my units. So we've got kilopascals, moles, Kelvin. Last unit standing, liters. So when I throw that into my calculator, my volume equals 17.276 liters. Least number of significant digits in my question is 3. So I take the 17.2, I look at that 7, and my volume of hydrogen gas that's formed is 17.3 liters. Okay. So volume of gas that's actually produced in excess sulfuric acid is 17.3 liters of hydrogen gas.